Okay, second half of projectile motion is just a combination of what we've learned before about motion at angles, and then combining that with what we've just learned about projectiles. So there's a couple things that have to happen before you even start the problem. Number one, if you have an initial velocity at an angle, your first step has to be to break it into its Vx and Vy components. And you do that by using sine and cosine, just like we've been doing in the past. So cosine will give you the Vx, and sine will give you the initial y velocity. And immediately when you see an initial velocity at an angle in a problem, you do that step. The next step that is very, very helpful is to solve for the total time. And the total time in the air is found by -2, the Vy, from right here where you use the sine angle Vi, divided by the acceleration due to gravity. And the -2 cancels out the -9.8. So in reality, when you're doing the math, if you wanted to leave the negatives off, that would be perfectly acceptable. And then the last piece of information that is kind of important to remember is that when you launch a projectile from the ground, it goes up in the air and lands some dx away. But the highest point, the dy, occurs at half the time. So when you're solving this equation and getting the total time, if the problem asks you for dy, you're going to use the time cut in half. Question 29 is simply asking you to take the Vi, which is 8 meters per second, at an angle of 80 degrees, and break it into the horizontal and vertical components. So split it into the Vx and the Vy. And the Vx is 1.4 meters per second, and the Vy is about 7.9 meters per second. Keep in mind that the Vx is constant. It never changes throughout the entire motion. This Vy is the initial. And as the projectile moves upward, it will get smaller. It will become 0 at the highest point, and it will get larger as it comes back down. And at equal heights, the magnitude of this number will be the same. Okay, question 30 is asking you to solve for four different questions, basically all broken into one. But half of these questions are things that you're going to just do automatically. Step 1, break into the horizontal and vertical components, Vx and Vy. Step 2, solve for time. Only after you've done that can we solve for the next two, and it doesn't matter the order you do them. We are going to look for the dy, remembering that you have to use half the time if you choose to use the dy equation, and then the next one asks for dx. I just want to remind you of another equation that you can use to solve for dy, an old equation that says vf squared equals vi squared plus 2gd. And this one will work at the highest point because remember, we know our vi, that is the y component, and the vf at the highest point is going to be 0. So this is an alternative to using the dy equation and one that does not use time. So I want you to go ahead and try to solve these, and I'm going to put the answers on the next slide. All right, time to check and see how you did. For the first question, the Vx is 26 meters per second, and the Vy is 15 meters per second. Putting that into the t equals -2 Vy over g equation gives us a time of 3.06 seconds. And then for solving for the dy, you could use the dy equals Vyt plus 1/2 gt squared. This g is a -9.8, very important. Or you could use Vf squared equals Vi squared plus 2gd. In either case, the dy is about 11.475 meters high. And the dx for this problem was 77.9 meters. Okay, we're just going to practice one more set, and then you can work on the Texas homework for this section or the unit homework. We have an initial velocity at an angle that needs to be split into Vx and Vy, and then we're just looking for how long did it take the ball to land. So we're looking for total time. So go ahead and try giving that a try. Try to solve for time. Our time is 0.83 seconds. Continuation of the same problem. How high did the ball go? We're looking for the dy. You can use either the dy equation or the vf squared equation. You choose which one you like better. In either case, you should get a height of about 0.85 meters. And the last part of this question, what is the range? And if you remember from a previous lesson, range is simply looking for dx. So dx equals vx times t. Use your vx from splitting the vi into sine and cosine, and this time needs to be the total time, not the time cut in half.